Bismillahirrahmanirrahim. This is Engineer Ishaq with you, testing and commissioning engineer, and the continuation of previous lectures on AVC panels and the automatic voltage control or automatic voltage regulator panels. We finished the portion of our ZIV relays. Now today we will brief you we will introduce you with the annunciator circuits and how the annunciator works. So first I will go to the manual. Show this, please come from this. Yeah, so now you can see this manual. Here everything is labeled, but going with every point it's very difficult. Just I will brief you what we have to do here for our settings and what are our requirements, what is the procedure to be followed. So now first see here, show it, automatic acknowledge or silence time selection. Now here we have the functions labeled according to the switches. So now we will first we will explain this and then we will show you practically. Now when the function is automatic acknowledge, for this we need switch 1. This is switches, switch 1, switch 2, switch 3, switch 4. Now when you need automatic acknowledge, for this you have to make switch 1 on. You can see it here. Switch 1 should be on if one's need automatic acknowledge. Then the second function, automatic mute. When one needs automatic mute, he should switch off the switch 1. Switch 1 should be switched off for automatic mute. Then similarly, disable automatic timer. For this you need to switch off switch 2 and switch 3. Enable 1 minute time delay. For that you need to switch on switch 2 and off switch number 3. Similarly, enable 4 minute time delay and enable 8 minute time delay. This is labeled accordingly. For enable 4 minute time delay, for this you need to switch off switch 2, switch on switch 3. Then for 8 minute time delay you need to switch on switch 2 and switch on switch number 3. Now see it here, this is the switch labeling in diagrams. This is the switch number 1, 2, 3 and 4, and this is showing, this is now in on position. Okay, this side showing on, this side showing off. I means 3 and 4 are switched off. Now if you need to switch on this, you have to move it to this side. 3 to make it on, move it to this side. Now show it what we will do here. For our AVC panels, we will make the function automatic mute. Okay, for that we have to switch off switch 1 and enable 1 minute time delay. We need 1 minute time delay. For that we will make on switch 2 and switch 3 should be off. So now we will show you this. Now you can see show him the switch on, the switches, 4 switches and remove these 2 nuts. This is the procedure which should be followed. this point please. These are the switches. 1 minute. This is switch 1, switch 2, 3 and 4. Okay, for automatic mute we need to switch off switch 1. Switched it off. 1. Is it off?
One off already.
Yeah, this is off already. And enable 1 minute time delay. For that we need to switch on switch 2 and switch off switch number 3. See, switch 2 is on, switch 3 is off. Sir, see, is it okay?
Close.
No, no, no. Yeah, so the next portion is function, no key and descriptions. And this section is explaining the functions and the status of LEDs and which functions having what feature. So then practically I will show you later, but first I will explain this. When you have enable function F0, what's its feature? Monitor current input contact state. If F1 is enabled, then what is its feature? Set signal contact non-alarm state. Similarly, F2, F3 having its separate features, and if we need the features we will make it on. If we don't need, we will make it off. Show the status LED, and the LED status will show you here. See, status of LED, and disable, enable, okay, and then normally energized and normally de-energized. Now the function which we need for this our AVC panel, we need these functions F2, F18 and F19. So we will make only changes in these three, and we will consider only these three functions F2, F18, F19. First I will explain it here, that what we need here. When F2, when we select function F2, okay, later I will show you how to select a function, how to change the status, okay, but first I will explain F2. When we enable function F2, what does it mean? Set individual channel repeat relay non-alarm state, and it means that my my relay should be in non-alarm state, okay. For this I have to make it normally de-energized, means my LED status should be made on, okay. After that I will go to the practical and show it you how to enable F2 and how to make it on for all 16 channels or 16 windows. Then F18 and F19, set repeat relays to follow logic. We don't need this, okay. We will make it disable. F18 we will make it disable for all 16 channels. Then set repeat relays to follow input. We need this function F19, so we will first select the F19, and then for all 16 channels we will make it enable. So this is what the next step I am going to do. Pardon me. Now you can see it here, this downside arrow. When you make it down, this you will make it down, you can edit the functions, okay. Now this status will show you editable, not editable, okay.
On or off?
Any edit, non-edit, okay. Okay, to enable or disable your function, you need to select from this point. Okay, now my function is disabled. So to make it on, please make it on. Okay, now you can see here, I am in function 0. How I should change my functions? You can see here, this is the function, upside and downside. Okay, so to change the function, okay, and after status, now this is off, any F0 is off. Now to make it on or off, you will change by these two. Okay, and to change the function, you will use these up and down for change. Okay, now we are in F2, because as I explained, we need to make a change in function F2. Similarly, this is window 1, 2, 3, 4, 5, 6, 7, 8, then 9, 10, 11, 12, 13, 14, 15, 16, and similarly these are the other 4 up to 20, but in this AVC panel we will use these 16 only. So we will make changes in these 16. Now as I explained, function F2, I should make it LED status on for all. To make it normally de-energized, and to make my relay normally de-energized, I will make the LED status on for all the 16 windows. So now you can see make it on. Window number 5, then window number 6, make it on, and similarly follow to make on all the LEDs for function F2, whichever the function, my relay will be normally de-energized. Show them the button, please. Which button you are pressing on the upside? Yeah.
This on channel.
So as I explained, the channel status, this is for make channel. This is for status. This is for functions. And now you can see it here. All the 16 windows are LED status are on. Now we will move to F18. We will change the function from F2 to F18, because we need change in F18 according to our AVC panel. Okay, now you can see here we are in function 18, function F18. Now as I explained, we need this disable, means that LED status should be off. For our requirement here in this AVC panel, we need to disable. Now these are already being disabled. Okay, all the 16 windows are disabled. You can see it here, no one glows. So this portion also finished. Then move to F19. Show it. Make change in F. Okay, now show it here. We are now in F19. We need to enable all these functions as I told earlier. So now you can see it here, all the LEDs are on, means all LED are blinking, so all are enabled. So this function and this section is explaining how to make changes in the function and how to select a specific function having a specific feature, which I told you in the table, which I show you that each function having a specific feature. So when we need a feature, we will on the LED status, and when we don't need this, we will make it off. Now the next step is the output delay response, time delay.
Yes.
Okay, so these having show it here please. This is, you can see it here, switch 1, switch 2. Now we will go to the table. What we need, according to that we will make changes in our correspondent switch. So now you can see it here, this the labeling channel switch, it is labeled here switch 2. So we will make change in this. Show it more clearly. Yeah, okay, you can see it here, switch 2, because from the table we need changes in switch 2 for channel 1, channel 2. Okay, now response time delay, how much time delay after which a channel should respond. So it having different kind of types of delays: 5 milliseconds, 10 milliseconds, 25, 50 milliseconds, 200 milliseconds, 2 seconds, 5 seconds, and 60 seconds. Now accordingly we will make the switch selection. For channel 1 having, in switch 2 having 4 switches, 1, 2, 3 and 4. For channel 2 having switch 2, in switch 2 having 5, 6, 7 and 8. Now for our AVC panel we need 5 seconds response time delay for our AVC panel. According to our requirements will be 5 seconds. So we have to make changes in switch SW2 like this pattern. So what will be the switch status? Channel 1, switch number 1, it will be off. Okay, then channel 1, switch 2, for 5 second delay it will be on. Channel 1 SW2 point number 3, it will be for 5 second delay it will be on. And similarly we will on 4 and 8 having a separate logic, which I will explain. Then similarly is the pattern for channel 2, 5th off, 6th on, 7th on, 8th also on. Okay, now it having a different logic. Show it clearly please. If channel 1 SW2 point number 4, when you make it on, it means 5 millisecond return to normal, and it will take 5 milliseconds to return to normal position. If you switched it off, it will means return to normal same as activation delay. So here we need this one, 5 second return to normal, 5 milliseconds to return to normal. So we will switched it on. Similarly, this logic is followed for point number 8. Now we will move to the channel side. Now you can see it here. As I told before, we need only change in switch SW2. So this is my card. This SW2. Show this. Show it clearly. SW2. We will make change according to our setting. This is SW1. Okay. Now
This vacation, I'm coming this.
take this. Okay. Off switch number 1.
Today? Yes. Maybe it's in.
Yes.
I missed
Off.
it because of
Show it. And up to 4 on. Now you can see it from the
I'm too much time.
in this second. These settings are according to our table.
The 100.
See,
100?
switch 1 off,
My father.
switch 2, 3 and 4 are on.
Father.
Now come to table please. 5th off,
Okay.
5th off, 6th, 7th and 8 are on. Inject it please. Insert.
No, thank you. No, everything, sir.
Okay, so per our settings, as I discussed it before, by showing you the cards for channel 1 and channel 2, and change the settings for switch SW2. We the settings which we make is for 5 seconds. Okay, so I'll just now we will check that is it working according to the settings which we made or not. So for that we will measure the time delay. Okay, so for that we need a timer to measure the time between start and stop. Is it coming 5 seconds or something like this or not? And then as I explained for point number 4, SW2 point number 4 on 5 milliseconds. So we will check this also as well, that is it taking the time of 5 milliseconds to return back to normal, or how much it takes. So we will measure the approximate, calculate the observed values. Okay, so for that I'll just explain in the drawings. First thing which you have to care about the DC in the drawings or in the panels, that is very important. For example, if your DC required is 24 volts and you applied 127, 120, 110 or 200 DC, so it's obvious that it will affect your the equipment. Okay, so it needs very careless, and if you are careless for this, and you will your equipment will damaged and you have to replace it again. So before making any test, you have to go to the drawing and see in the drawing what is the requirement of DC or AC for my equipment. So I will show it here in the drawing that what's required for annunciator. Show it this please. Now you can see it here. This is my annunciator. Okay, my annunciator need energy of 24 volts. Okay, So if I directly energized it from 127 or without rectification, without transforming it to 24 volts DC, so it's obvious that my equipment will be damaged. So this is the first thing you have to care. Carrying out any experiment, you have to go to its specification. Before performing any test as a testing and commissioning engineer, you have to take care of this. Now you can see it from the drawing. Channel 1, okay, common, supplied to all. See, this point is connected to all of the channels, and this is internal, no need to provide any supply. You can see it, positive supplied from this point to all the annunciator circuits. Now for timing test, what we need to check the timer for channel 1 or window 1, simply we need to start the timer for this, because this is our input, this is our output. So we will set our timer like this. We will make the connection from start to stop. How much time it takes, it will automatically stop. So now I will show you here in the timer. See, this is a connection which I made X72.1. okay, so it will go through my MCB and then it will be connected to X72.17 for channel 1 or for window 1. Then I will keep this point same, because it is common, provided to all the circuits of annunciator or all the channels of annunciator, I would say. Then 17. After finishing this check, I will just move to from point 17, show it in the drawing, to point number 18. You can see it clearly. Make it clear. Yeah, you can see it now. Similarly 19, 20, 21, that's how the pattern which I will follow. And similarly for the output side, I will make the jumper between points number 17, point number 17 and point X82.2. we will make the jumper to measure the time. Now for this time measurement test, we will make jumper between these 2 points to start our circuits, to close the path and test the time. Okay, now this is the arrangement from normally open to normally close, start timer, and stop from normally open to normally close. So now according to our arrangement, make connection for X72.17 to X82 point number 2. Then I will on the MCB and we will measure the time. Start it. Now I will on the MCB and measure the time. Okay. Now alarm also beeps. This is for W1. So we observe the time, it is 5 point, now you can see the time 5.012, and the arrangement was for 5 seconds. So here is the table. You can see it here, 5 seconds according to my setting, and measured value is 5.01. now you can see it clearly. We measure the time, that is 5.01 seconds. Now for reset, the time delay according to setting should be 5 milliseconds. Now we will measure this one. For that we need from normally closed to normally open. You can see the change. We will reset our timer and start. You can see it now, 0.026, approximately equal to 5 milliseconds. So we performed the test, the timing test for W1. Now for the test for W2, what we need? We need to convert from X72.17 and make the connection to X72.18. okay, and for output we will connect to X82.3. so make this connection please. X72.18 we will make, as I explained and I told you earlier, that we will make this point common because it is connected to all. So make the connection for X72.18.
Okay, reset.
And
Reset.
okay, ready? Connection is ready?
Yeah.
Okay, I will start the timer again for W2. Now you can see here, this is blinking and you can hear the alarm as well. After acknowledgement it will stop. I will measure the time, that is 5.01. so you can see it here from the table, 5.018. here I measured is 5.015. this procedure will be followed for all the 16 channels. Now for reset time delay measurement, I will do the same from normally closed to normally open, and we will measure the time. Reset and then on. Same delay, approximately equal to 5 milliseconds. You can see it from the table. So if you understand this pattern, we will follow the same pattern and just we will measure the time. Now we will move from point 18 to point 19 of our terminal block X72. Okay, and same pattern will be followed. Here we will move to X82.4 and we will measure the time and delay to come to its normal position. And we have the final table for you. You can see it labeling the channels, channel 1 up to channel 16, because we in this our AVC panel we are using 16 channels, and this is the 5 seconds for whole arrangements, and then we measure the time. This column show you the measured values and then the reset timing 5 milliseconds, and what we measured, what we observed, this table is showing you this. And similarly alarm, and is after 5 seconds you heard alarm for W1, W2, so it is okay. So similarly okay for all. you can repeat it.